With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the question is arrange the following as per the instructions given in the bracket, increased order of ionization energy. So in this question they have given us some elements and we have to arrange them in the increasing order of ionization energy. So first of all we need to know what is ionization energy. So ionization energy is the amount of energy that is required to remove one electron from the outermost shell of an isolated gaseous atom. Okay, so it is the amount of energy required to remove an electron from the valence shell or outermost shell of an isolated gaseous atom. So this is the definition of ionization energy or ionization enthalpy. Okay, so let's now arrange these elements in the way they are present in the periodic table. So sodium is present in the period 3 of the periodic table, something like this, sodium. Then comes potassium in the period 4, like this. So these two elements belong to group 1 of the periodic table. Then we have chlorine, sulfur and silicon. So chlorine, sulfur and silicon, sulfur and chlorine all are present in period 3, like this. Okay, so they are silicon, sulfur and chlorine. They are arranged something like this, one by one. Okay, so these are all the elements that are present. See the trend of ionization enthalpy across the period and down the group. So across the period, if you move from left to right, what happens is the number of electrons in the outermost shell keeps on increasing, but the number of shells remains the same. Because of the increased number of electrons in the outermost shell, there is an increase in the nuclear charge. So what happens is because of the increased nuclear charge, the nuclear attraction towards the outermost shell increases, and so it pulls the outermost shell towards itself. Now the outermost shell and the electrons in the outermost shell are very tightly bonded, and so it is difficult for us to remove an electron from the valence shell of these atoms. Okay, so for removing an electron from the valence shell of these atoms, a large amount of energy is required, and thus the ionization potential of elements on the right side of the periodic table is higher, and thus the trend of ionization potential is it increases from left to right. Okay, because what was ionization potential? It was the amount of energy required to remove an electron. So as I said, a large amount of energy will be required, so thus ionization potential will increase. Let's see what happens as we move from top to bottom. So as you move from top to bottom across down the group, what happens is the number of shells increases in an atom, and the number of electrons in the outermost shell remains the same. Because of the increased number of shell, there is an increased distance between the nucleus and the outermost shell, and so the nuclear charge decreases, and because of the decreased nuclear charge, the electrons in the outermost shell is very loosely bonded with the nucleus, and so it is easy for us to remove an electron from the outermost shell of elements that are present on the lower side of the periodic table. Okay, because they have increased number of shells, and so the distance between the nucleus and the outermost shell increases. So if it is easy for us to remove electron, the amount of energy required to remove this electron will be less, and so the ionization potential as we move from top to bottom decreases. So this is the trend of ionization potential. Now let's arrange these elements in the increasing order of ionization energy. Okay, now as I said here, from top to bottom the ionization potential decreases, so potassium will have less ionization energy as compared to sodium. Okay, so it will be something like this, and as you move from left to right, as I said, ionization energy increases, so the trend will be something like this: potassium, sodium, silicon, sulfur and chlorine. So chlorine will have the highest ionization energy. That was the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.